Two respected programmers recently gave almost opposite answers to one question. Michio Hashimoto said, "I read the code." Uncle Bob said he does not read the implementation produced by his agents. That sounds like a fight between engineering discipline and blind faith. It is not. Both men insist that the human remains accountable. The real disagreement is where human understanding should live when machines can produce more code than we can comfortably read. That is no longer a philosophical question, it is becoming the daily operating question of software teams. Mitchell described a workflow where different models plan, implement, and judge a change. Someone asked how he knows the final result is good. His answer was 4 words. "I read the code." That answer fits the kind of boundary he has also defended in open source. If you submit a change, you should understand it well enough to explain it, maintain it, and fix it. The code remains the shared object that future humans inherit. Uncle Bob takes a different route. He says his agents work from specifications, unit tests, Gherkin scenarios, mutation testing, QA, metrics, and final verification. He does not treat generated implementation as the primary interface. His sharper line is, "I am the engineer because I am accountable." So this is not responsibility versus irresponsibility. It is source comprehension versus an assurance system built around intent and evidence. Both positions reject the same bad habit: shipping something you cannot defend and blaming the model when it fails. Mitchell keeps understanding close to the implementation. Uncle Bob moves much of it into specifications, tests, observable behavior, and acceptance criteria. Their disagreement is narrower and more useful than the internet version of it. What must a human understand? Every relevant line or the contract, evidence, boundaries, and the failure modes around those lines. The community argument became intense because code review has never done only one job. Yes, it finds defects, but it also gives the reviewer a mental model of the system. It creates shared language inside a team, and it makes responsibility explicit. Another person has looked at this change and is willing to let the organization inherit it. Automation can replace part of defect finding. It does not automatically replace those other functions. The Reddit camp worries about maintenance. If nobody understands the implementation, the same agent that built the system becomes the only guide capable of explaining it. That is a fragile loop, especially during an unusual failure. The verify outcomes camp sees a different trap. If AI can create a large change in minutes, then manually reading every generated line may erase most of the leverage. Humans also miss bugs. Better specifications, independent tests, runtime checks, and observability can sometimes provide stronger evidence than a tired reviewer scanning a diff. A third concern is learning. Reading and changing code is how junior engineers build judgment. A workflow optimized only for throughput may produce software faster, while producing fewer people capable of maintaining it. None of these concerns is imaginary. They are different costs, paid at different times. This is already happening at scale. OpenAI described an internal product built from an empty repository with no manually written implementation code. After 5 months, the company reported roughly 1 million lines and about 1,500 merged pull requests. Humans shifted toward specifying intent, building the environment, and creating feedback loops. OpenAI also says human pull request review became optional in that experiment. It is impressive, but it is still a company-reported greenfield experiment, not proof that every mature system should work this way. Cloudflare built another kind of answer. Up to 7 specialized AI reviewers, coordinated into one review, with different depth for different risk tiers. Even there, database migrations are explicitly exempted from the generated file shortcut because generated does not mean unimportant. And Godot exposed the organizational cost. Its maintainers said AI lowered the effort required to create pull requests, while reviewer capacity did not increase. Their response was not simply ban AI. It was to insist on human approval and a contributor who can take responsibility and fix the work. The common pattern is clear. Code generation is becoming abundant. Verification, attention, and ownership are becoming the scarce resources. In my own work, I do not use one rule for every artifact. A disposable script, a private prototype, or a copied data file can often be judged by its result. If it fails, the consequence is small and the work is easy to discard. My posture changes when AI touches a critical system or a system of record. A critical system is defined by consequence, permissions, money, privacy, deletion, security, or an operation that is hard to recover from. A system of record is defined by authority. It is where the organization decides what is true about a customer, an order, a balance, or a contractual state. Those categories often overlap, but not always. The important point is that 5 lines which write authoritative state can deserve more attention than 1,000 lines of disposable interface code. And the rollback is not the whole recovery plan. Reverting code may stop the next bad write. It may not restore records already changed, messages already sent, access already granted, or decisions already made from the wrong state. My rule is simple. Review depth follows authority. For disposable work, verify the outcome and move on. For shared or production work, add independent evidence and make sure someone has a usable model of the system. For critical system pull or system of record write, inspect the relevant source path, state the invariant that must remain true, identify the signal that reveals divergence, and name the recovery path and the human owner. These are cumulative. Tests do not cancel the need for understanding, and the reading does not cancel the need for tests. The unit of review is no longer just the diff. It is the responsibility chain, intent, implementation, independent evidence, authoritative effect, and recovery. The obvious objection is that risk tiers can become bureaucracy or an excuse for sloppy work below the line. That is true if the boundary never moves. A private prototype can become a team dependency. A temporary script can start writing production data. When its authority changes, the review level must change with it. And the learning is a separate axis. A low-risk task may not need deep review for safety, but a junior engineer may still need to read it to build judgment. So, should you read AI-generated code? Sometimes every relevant line. Sometimes only the critical path. Sometimes the outcome is enough. Before deciding, ask 4 questions. What can this code change? Who or what inherits the result? If the commit is reverted, can reality also be restored? And who can explain and repair the failure without asking the same agent to grade its own work? AI can generate implementation. It can generate tests. It can even generate a review. It cannot own the consequence. That is still our job.